G'day, Glenn Morris here from the Smart Energy Lab. I'm here on day 2 All Energy, and boy, what a conference it's been, or an expo it's been. I'm here with Jason from eLumina. G'day, Jason.
Hi, how are you, Glenn?
I'm good. My feet are worn out. How are yours?
Oh, look, my legs are tired, my feet are worn out. I need to lie down after this, I know that much.
Well, before you get to lie down, you're going to tell us a bit about what eLumina do, and we're standing in front of this big thing. Tell us a bit about eLumina.
Well, eLumina is an Australian business, and we've been around for about 2.5 years now. And our focus is on what we're calling low grid, no grid, or off grid fast EV charging. So our products really support particularly people in rural and regional areas to get access to fast and ultra fast charging, even if they don't have a lot of power available from the grid. So we're really filling what we see as a niche in the current market.
I mean, how can you provide that when there's no grid or, weak grid?
Well, the magic is we can use a battery to effectively boost the available grid power and multiply it by several times and provide a genuine fast charge for vehicles. So, for example, we could take as little as 10 kilowatts to 70 kilowatts. We can turn that into 250 or 400 kilowatts of charging power for one or more vehicles.
So a crude analogy is you can take a garden hose and fill up a water tank to run a fire hose.
Exactly, that's right, correct. So we're doing exactly the same thing, and I love the plumbing analogy. That's perfect.
So tell us a bit about the equipment we're standing in front of. This is pretty big.
Yeah, so this is the new product that we've just brought into the country. So this is the large version. So it can operate off solar, AC, or a combination of both. So you can really use some renewable energy as well to charge the battery, not just the grid. It's got a large 350 kilowatt hour battery in it, and that can give you up to 400 kilowatts of DC charging power. And the other difference with this unit is it uses satellite dispensers. And for those who are not in the industry, essentially
it's not coming from space.
No, not coming from space. It just means that the actual plugs where you connect the vehicles are separate from the power cabinet. So the power cabinet can go close to where the grid supply is or whatever is supplying the unit. And then the satellites, as they're called, can go separately closer to where the vehicles are, and they just take up a lot less space.
So it's effectively just a dispenser.
Exactly, a dispenser.
And all the power conversion happens at somewhere close to the supply.
Yeah, that's right. So you minimise the need for a lot of AC cabling to go around the site, and then you can just have some DC cabling going from the power cabinet to the satellite units. And that's just more cost effective to do it that way, particularly if you don't have much room.
So this 350 kilowatt hour battery can deliver 400 watts of DC power, so it's a 1C battery.
Yes, it is a 1C battery. So we're specifically targeting large capacity vehicles like trucks and buses with big batteries, and so they can come and get a significant top up in a very short period of time. So that 350 kilowatts, we can push that out in an hour if we need to.
Wow, I think I'm getting tired. I just said 400 watts. I think I meant 400 kilowatts.
That's right.
Not a light bulb.
That's right. I mean, kilowatt hours, kilowatts.
Who cares?
So who cares? It's all energy at the end of the day.
Now, you said you can connect PV to it, so you've got a solar charging capability?
Exactly. So you can directly connect a DC coupled solar PV array up to 40 kilowatts in this unit. And also you can do completely off-grid and do up to 80 kilowatts of DC coupled solar. So we're doing some sites where we're putting in a small solar array mixed in with a connection to a biodiesel generator. And the fuel for the biodiesel generator comes from the kitchen of the roadhouse where they're doing the cooking. So they take their used cooking oil, they put it into the reservoir for the biodiesel generator, it's get filtered, and it generates, let's say, a renewable source of fuel to help offset when the solar is not providing power, and you can still charge the battery.
Wow. I can think of another use case. You probably thought of it as well. I was driving in Outback WA one time, pulled up at this roadhouse in the middle of nowhere, and filling up, and probably they get a customer every hour. Hardly anyone goes there. They've got a couple of dongers out the back for people who can't, need to sleep. And they had this thumping gate generator. And it was like a 250 kVA generator running. And I said, how big is that? And they kind of looked at me and they said, oh, yeah, mate, that's 250 kVA. We got it from a mine site cheap. Yeah. And I go, so it's running, just a few hours a day? No, it runs all the time, mate. And I go, what? Just to run a roadhouse and a couple of air cons? So putting in a battery in to charge it from a generator would be a much more efficient use of that fuel.
That's right, because you would not need to run it all the time at all, because once the battery's charged, it's charged, and then until someone comes along and uses that energy, there's no need to keep the generator running 24 hours a day. So in that case, yeah, it'd be much better.
Right, so you can augment inefficient use of rotating machines.
Yes.
You can use renewable energy directly, solar.
Yep.
You can use the grid where you're capacity constrained,
Yes.
the garden hose to fill up your water tank.
That's right.
Wow, and you can do DC charging, so you actually have a DC charging module.
Yep, exactly. So there's DC-DC converter modules inside, and in this particular unit, there's 10 of those, 40 kilowatts each, to give you up to that 400 kilowatts of output power. So it's just coming straight from the battery, going through those converter modules straight to the one or more vehicles.
It's very efficient then, DC-DC, very, very efficient conversion.
Minimal losses. The efficiency of the unit overall is very high, and it's great there because you want to maximise what you're getting out of the little power you've got to make sure you're using it as efficiently as possible.
Now this is the 350 kilowatt hour unit. Do you have other sizes?
We do. So we have the baby brother or baby sister of this unit, so we call that the D3. It has a smaller battery, half the size, 175 kilowatt hours, and maximum output charge for that is 250 across 2 vehicles. That's more like a traditional charger in the sense that you've got the connectors integrated with the unit.
Yep.
Rather than having separate satellite units. So it's good for locations where there's less vehicles or less space for vehicles. And the principle is exactly the same. It can have solar, it can have grid, or a combination of both.
Yep.
So it works in exactly the same way, it's just smaller.
I think I should have showered this morning. I got a fly chasing me.
I don't know where it's come. I saw a pigeon earlier.
Yeah, I saw a pigeon go fly past. So what about events? So say you're holding an event in a rural area, could you just temporarily relocate one of these for charging?
You could, and we had a very interesting application of that recently. We have a client over in Western Australia, a construction business, and they want to use batteries to power their site huts and also their electric vehicles that they use when they're going from site to site. And they want to be able to take their power with them. So essentially our product presents a good solution for them because they can charge it up at their depot, take it out to the site, and then they've got access to power. They can run their site huts, they can charge their vehicles during the day, and they have a solar array that they roll out themselves. So while they're running during the day, they can keep the battery topped up.
Right, so they have a portable solar array.
Solar array, so it rolls out. I mean, it's sort of like that 5B solution that sounds like it, but they've developed this themselves apparently. So they bring it with them to their sites, they roll it out, plug it into the battery, in this case our battery, and they also get the bonus of the EV charging. And because these models are both bi-directional on the input side, they can put some power into their site loads from the battery as well.
Now, if you're a customer who has the grid and say you choose to get one of these because you're capacity constrained,
Yes.
and you need to be able to do fast charging,
Yes.
is there any other benefits that you can provide?
I think the other benefit is around the ability to, as I mentioned briefly earlier, the building to battery to grid, I should say, or battery to load. Mm-hmm. So if there is capacity in the battery and they're not charging, then they can use some of that energy to power some of their site loads, or even to give back to the grid to maybe earn a little bit of revenue.
So like arbitrage,
like arbitrage,
they could be using cheap off-peak power to charge the battery, and then use that energy during the day.
Yeah, and sell a bit back as well if they need to during peak times. So whilst it's not its primary usage, it is an extra benefit that they can get some use out of.
Yeah.
So we think it's a good feature, just adds another element to the overall product.
Yeah, cool. So if you haven't realised yet, we're in Australia because we do this a lot.
That's right. The Australian salute.
That's right. Even indoors we do the Australian salute.
We can't avoid it.
We can't avoid it. Wow. So Jason, that was pretty impressive. And thanks for showing me around the Illumina stand, the D3 and the
S400.
S400.
Yeah.
It's the big boy.
That's right. So thanks very much, Glenn.
Cool.
Appreciate it.